So let's see. Okay, maybe this is not required for today's class. Okay, so last class we finished projectile motion. This class we'll be studying something called circular motion. Okay, so these two are the most important topics in this entire chapter. Okay, so first class I think we saw vector addition and vector subtraction. Second class we saw something about basics of vectors such as unit vectors, equal vectors, opposite vectors, those kind of things. And then we studied something about motion in a plane or 2D, right? So we studied that the displacement in x direction and y direction can be combined together to be seen as one single motion. Or in other words, motion in 2D can be split into two components, one in x direction and one in y direction. The same thing we said V is equal to Vxi plus Vyj. Similarly, acceleration A is equal to Axi plus Ayj. Okay, so that's what we studied as motion in 2D. And then we studied the application, which is projectile motion. Okay, so in projectile motion, one thing I forgot to tell you is important concept. Maybe I can talk about that. So okay, if you see some of the chapters, I've been uploading it in the YouTube also for the 11th physics. Okay, so you can click on this and you can go and watch this projectile motion classes. So I started a separate playlist for this P04. So 11 P04 means 11th physics chapter 4. Okay, so there are some demonstrations which are recorded here. So if you go to playlists, so far I have been uploading only the 12th physics chapters over here. So right now I have started uploading the 11th also. So maybe the previous chapters also I have to upload. And if you go to physics demos, right, view playlist. So I'd recommend you to watch this projectile motion demo. Okay, so okay, so let's see. Of course, I was trying to take a slow motion of this, so probably it didn't work very well. But what I'm trying to do here is, so this guy, he's dropping one ball straight over here, and then one ball he's kind of, hitting from the table. So that means, yeah. So look at this. One ball is dropped, one ball is given a horizontal velocity. So it's taking a projectile motion like this. That means you see when this ball has traveled say 5 centimeter, this ball in the y direction would have traveled 5 centimeter. So if you see this ball and this ball, it will be almost in the same level. Okay. So maybe there is a small difference because we are not able to do it perfectly. Okay. If you really do it perfectly, you will see that this ball and this ball will be in the same level. Look at this. I'm just chopping it every point. And very interestingly, when you're doing the experiment, right, you will not be able to see this because it happens in a fraction of a second. But when it hits the ground, right, you will see the same tick sound. So both the balls will be hitting the ground exactly at the same time. So I'd recommend you to try this experiment. Okay, one ball you have to drop it, one ball you have to give a horizontal velocity, which means it will take a projectile path. So you see here both are hitting the ground, and if you see the video, you will see a tick sound exactly at this same moment. So what this means is even though the projectile motion is moving in x and y, you can consider it as a two different path, one in x direction, one in y direction. So this is same like a ball being dropped in the y direction. Okay, so what I'm trying to say here is, so when you give a ball like this, it's going to take a projectile motion like this. And if you had dropped a red ball in the same location, same height, right? When this ball had come here, this ball would have come here. When this ball had come here, this ball would have come exactly in the same level. And this ball had come here. This ball would have come somewhere here. So what I'm trying to say here is this yellow ball, even though it's moving in x and y direction, right? If you consider the y direction alone, it is same like this red ball. Okay, so when this has moved 5 centimeter, this has also moved only 5 centimeter in the y direction. If this has moved say 10 centimeter here, this had also moved 10 centimeter here. Anyone following what I'm saying? So this is an important concept. Okay. Can anyone tell me why do you think I showed this red ball closer here, whereas this is slightly bigger gap and this should be bigger gap even? I think I should have drawn a little bit farther here. Anybody? Any idea? I'm sure you have seen some textbook diagrams. Here I had shown smaller distance. Here I had shown bigger distance. Here I had shown bigger, more bigger. I'm sure you know the answer. Please tell me the answer.
At each second, the acceleration increases, so the distance also increases.
Wrong. Any other answers? What is increasing? Acceleration or something else? Does the acceleration change? Acceleration due to gravity.
So the speed increases due to gravity.
Yeah. So Chaitanya, what you meant to say was velocity, right? Speed, not the acceleration.
Yes.
So acceleration remains constant. So take it down. Acceleration is a constant. Okay, which is g is equal to 9.8 meter per second square. So what is increasing is the velocity. So since the velocity is increasing, in the first second, maybe it was going at 1 meter per second. In the second second, it was going at 10 meter per second, which means it will be covering more distance. In the third second, it will be going at 30 meter per second, which means it will be covering even more bigger distance. So it means the distance covered will be more as the velocity is increasing. Okay, so that's why generally if you see the textbooks, they will show a picture like this. So, oh, Elvin, are you saying you are the one who answered that? Was it Elvin or Chaitanya who was answering it?
That was Elvin, sir.
Elvin, okay, very good. More your voice is somewhat similar. Okay. Okay, so one thing I didn't talk about was, okay, as I told you, go to this YouTube video and try to watch this physics projectile motion demo. Okay, you can search it in Guru Academy and Labs. Go to demos and you can find this. Okay. And you will hear the noise when it hits the ground, the tick sound from the ball. If you have a table tennis ball, right, you can try this. Why I say table tennis means when it hits the ground, you will hear the tick sound. So that means both the balls will be reaching the ground exactly at the same time. Okay, so this is a very interesting experiment which you can try it in your home. Okay, so whenever possible, I keep on saying, if you do some experiments, right, and if you, with a lot of interest, if you do the experiments, it means you are going to become a scientist. Okay. No, sir, I'm just studying just to get some marks, pass, and then go on do something means then that's your choice. Okay. But if you really like the subject, you have to do some experiments. Okay. Remember, physics is nothing but natural philosophy. In Galileo's time or Newton's time, it was called as natural philosophy. Sophie refers to knowledge. Okay, Phil refers to nucleophile, electrophile. So phile means loving or liking. So love for knowledge. Okay, so natural philosophy means you are studying the nature. Okay, so only to certain extent you can study from books and teachers. Okay, if you really want to become a scientist, then you should learn from nature. And how can you learn from nature? If you read only books and YouTube videos and teachers, then they are just repeating whatever is already there. Okay, you cannot learn something new. So if you really want to learn something new, you have to start doing experiments. And I'm not asking you to do some nuclear physics experiments, which is not possible for you. But I'm sure you can take two balls and you can try this experiment. Okay. So if you have that interest, then you can confidently take these kind of subjects in college to study this. And not only that, when you do the experiments, you will understand the subject even more better and you will have the interest for the subject. Okay, and one more thing I forgot to tell is, when let's say you are standing on a cliff, and let's say you're standing here, and then you are throwing a ball in the horizontal direction. So what will happen is, the ball will take a projectile motion like this, like a parabolic path, like this. So if this is the ground, it will be hitting over here. So whatever concepts, whatever principles we used in the previous thing, right? The same thing are applicable over here. Okay, when you do the problems, you'll understand this. So for now, I'm not going to confuse you with this. Okay, so whatever you studied already, you can apply the same concepts. So there is absolutely no new formulas, equations of motion. If you know it, you can do it. Okay. Only thing, as you do the problems, you'll understand it. Okay, so as a continuation from the projectile motion, I've been talking about this. Okay, I didn't discuss this in the previous class. Okay, now in this class, my actual plan was to get started with circular motion. Okay, so that's what I wanted to get started today. So circular motion is also a very interesting and very important topic. Okay, as I've been telling you, all these things will be coming in your engineering. If you don't know the ABCDs of this, you'll be struggling in your engineering college. Okay. So if I take a ball and if I attach it to a string and if I spin it, right? So what happens is, I'm giving some kind of force from my hands over here. Okay, let's say I'm holding it from here. Okay, so it's going to spin around like this. So if I say I'm spinning at the same speed, right? Let's say it's going at the speed of say 5 meters per second. When the ball is over here, I should show it like this, 5 meters per second. When the ball is here, it will be 5 meter per second this way. When the ball is here, it will be tangential. So this is your tangential direction. If I take some other location over here, it's again tangential, 5 meter per second. Okay, of course, 5 meter looks very high. Maybe I can take it as 1 meter per second. Okay, again, as long as you understand the concept, it's fine. Okay, so how do I know that? Well, I have a simple experiment in the lab. You take a ball, again, you can try this in your home. You can take a simple table tennis ball and you can, put some sellotape and take a thread and, put this sellotape around this thread on this ball and you start spinning it around, right? And one instant, right, when the ball is here, if you stop it, you will see that the ball will be flying around straight like this. If you try it in another instant, when the ball is here, it will fly straight like this. When the ball is here, it will fly straight, and then it will fall like this. So that means as long as you are giving some force in your hand, right, it goes around the circle. The moment you stop the force, right, what happens? Does it go in the circular motion or does it go in a straight motion?
It goes in a straight.
Straight motion.
Can anyone tell me why does it go in a straight motion? Why can't it go in a circular motion, or why can't it go in a parabolic path, or why can't it go in a rectangular or some other curve like this? Why can't it go like this? Any idea? I know it sounds silly, but why should it always go in straight line? Nobody knows. I'm surprised.
So because the force is acted on that direction.
Well, I stopped acting. I stopped giving the force. Only because I stopped the force, right? It's going in a straight line. Anybody?
The direction changes only when we apply a force, sir. But when we
Okay.
stop applying the force, it moves in a straight motion.
Okay, very good. So, what is Newton's first law? We'll study this in the next chapter, chapter 5. So, what is Newton's first law? You studied that, sir, but we forgot, right? In 9th standard, or when did you study? 2 years it's been?
Mine stands, sir.
Yeah. So, if I leave a book on my table and if I go away in the office, right? 2 days later, if I come back, the book is going to be still in the same place. Is
So
that
a
right?
body will stay at rest until and unless an external force acts on it.
Acted upon by
Rest or motion, sir.
Okay. Okay, very good. So object will stay in state of rest. Okay. State of rest or of uniform motion. I think all of us understand the first part, okay, state of rest, because if you leave your book on the table, if nobody puts some force on the book, right, it will remain in the same place even after 2 days or 20 days. Okay. But what does this uniform motion mean? Anybody? No idea. So uniform motion means constant velocity. So this happens only in deep space or in space. So if you become an astronaut, okay, so right now you are studying 11th standard, so maybe you have to study your 12th and then 4 years of engineering or science, and then maybe another 2 years of masters. Maybe you go to become, join ISRO or NASA or something, and you become an astronaut, right? Let's say you're going in a rocket, and if you open the window of the rocket and if you throw a ball, right? If you are in deep space, what will happen is the ball will keep on going in a straight line. Why? Because there is no other force, so it will keep on going for ever and ever and ever. But if it comes closer to some other planet, right, this planet will start pulling it down, which means it will start spiraling around the planet and it will fall into the planet. Okay, so that means when I say deep space, there is no other big objects, no other big planets, no other big stars. And that is what we mean by deep space. So in deep space, there is no other force. which means it will keep on going in a straight line. Okay, and that is what is meant by uniform motion or constant velocity. So that means what Newton says in this law is either it has to be in rest or it will keep on moving in a constant uniform motion or constant velocity. When I say velocity, it is in straight line. Okay, there is no circular motion or there is no other direction. It just keeps on going in the same direction. That's the meaning of constant velocity. Okay, unless acted upon by F external, an unbalanced external force. Okay, give me a sec. I'm getting a urgent call. Okay, can you hear me?
Yes, sir, you're audible.
Yes, sir.
So unless acted upon by an external force, okay, by an external force. So take it down the statement, okay. I may have changed the words a little bit, but the basic idea is state of rest or of uniform motion. Body continues to be in state of rest or of uniform motion. What is meant by uniform motion? You should know the meaning of this constant velocity unless acted upon by an external force. So let's come back to this. Why on earth I would be talking about Newton's first law when I'm talking about circular motion? Well, as long as you give some force in your hands through the string, right? What happens is the ball is getting pulled towards you. Okay, listen carefully. You are giving some kind of a force, which we call it as centripetal force. So as long as you keep giving this force which is acting towards you, you are pulling the string. Okay, and that is why it is going around the circle. The moment you stop the force, right, when the external force is zero, what happens is Newton says that it goes in a straight line. It doesn't take a circular path. So to make it go around a circular path, you have to give some force. The moment you stop the force, it will go in a straight line. And this we call it as tangential line. Okay. So how do you think Newton came up with this idea? I'm sure it's not by reading books alone, right? I'm sure he read Galileo's works. A lot of Galileo's work are represented in Newton's work, right? But then reading books alone will not help you. You have to do some experiments if you want to become a scientist. Okay. So that means you know something about centripetal force. So the force will be acting towards center. So when the ball is here, the string is here. So that means it's acting towards the center. When the ball is here, the force is acting towards center. When the ball is here, the force is acting towards center. Okay. And that is what we mean by centripetal force. Any questions? So you should know why it is going in a circular motion and why it cannot go in a circular motion the moment you stop pulling the string. Okay. This, when the speed is constant, right, we call it as uniform circular motion. So take it down. There are two types of motion which we will be studying more about uniform circular motion. So when I say uniform circular motion, right, the speed is constant. But look at the diagram here and tell me the velocity direction, is it changing or is it same at every instant?
Sir, velocity will change, sir. It is not
Velocity
uniform.
change. So why? Because the direction is changing. Everyone following? Even though the speed is same, the magnitude of the velocity is same, but the direction is changing at every instant. What will be the direction of the ball at every instant? Anybody? What will be the direction? Tangent to the circle. Yeah. So that means, so that's correct. So you should say tangential direction of the circle. So speed is constant. So but direction is changing. Direction is changing in every instant. Okay, which means velocity is changing. Velocity is changing in every instant. Okay, which means we say that magnitude of the velocity is constant. So speed is constant means another way of saying this is magnitude of velocity is constant. Okay, so all these things are different terminologies you should be aware of. Now, since you know what is uniform circular motion, right? Can anyone tell me what will be non-uniform circular motion? Something is non-uniform. What is non-uniform? Here we said uniform means speed is constant. Non-uniform means
Speed is changing.
speed is changing. That's all. Very simple. So that means if the speed is changing, right? Speed itself is 1 meter per second, 2 meter per second when you are accelerating, right? So you are slowly increasing the speed. So that means speed is changing. Of course, the direction is also changing, right? In a circular motion, direction is also changing. Okay. Okay, so let's see. I'm going to go into slightly interesting but slightly tricky topics. Okay, so centripetal force means I'm going to do the derivations later because I'm more interested in making sure that you understand the concepts first properly. Okay, if you understand the concepts, the mathematics any book can give you, right? So the derivations are nothing. Okay, if you know the mathematics, you can do it. So understanding concepts is more important. So that means centripetal force acting towards the center. So this is the force this is the force responsible for circular motion. Okay. So if you don't have this force acting towards the center, there is no circular motion. So very important concept. Centripetal force, we have a formula. Again, as I said, we will derive this later. Okay. Derivation is not a big deal. mv squared by r. But you know that force is equal to F is equal to ma. That means in place of mass, you have m. In place of force, I said this is centripetal force. In place of acceleration, I have v squared by r. So that means we call this as centripetal acceleration. Centripetal. And by the way, petal, centri means center, petal means towards. Okay, I think it's some Latin words. So centripetal acceleration. Okay, so this is called centripetal acceleration. So usually if I say acceleration, right? Acceleration is responsible for what? If I say if I'm pressing the accelerator, what happens to your car? If I'm pressing the accelerator, what happens to your car? It gains
Moves
speed.
faster.
What did you say?
It moves
Speed
faster.
will, yeah,
Moves
speed will
faster.
increase.
Yeah, the speed increases, moves faster. Yeah, right. But when I say centripetal acceleration, what's happening is here you can say the velocity is changing, right? You can also see it as velocity changing. But when you say centripetal acceleration, right, in uniform circular motion, what's happening is the speed is remaining same, but the direction is changing at every point. So who is responsible for this changing direction? This centripetal acceleration. So that means centripetal acceleration is responsible for the direction change. Direction change of velocity. Okay. Of course, acceleration and force are very closely interrelated. So this and this might sound very similar, but you know that F is equal to ma. One more concept which is coming in the, I think I already talked about it in one of the previous topics. So listen carefully. When I throw a ball upwards, the velocity is upwards, whereas the gravity is downwards. So when the velocity and when I say gravity, right, I can also call it as acceleration due to gravity. So this is your acceleration. Okay, meaning the force is acting downwards. F is equal to mg. You can call this as acceleration A is equal to minus g, or you can say force of gravity is equal to m into g, the minus. So both are interrelated, right? So now my question for you is, velocity direction is this way, but the force direction is this way. Okay, what happens to the speed? Does it increase or decrease when the ball is thrown upwards?
Surely it will decrease.
Decrease, right? It keeps on decreasing until it becomes, velocity becomes 0.
0.
And when the ball starts coming down, what happens? Velocity is this way and the gravity is this way, or I can say acceleration is minus g this way, right? So both are in the same direction. What happens to the velocity? The
Velocity increases.
increases, right? The speed keeps on increasing. So here, motion direction. So the velocity direction we call it as motion direction. This is the force direction. So that means take it down properly. When so motion direction, or you can say direction of motion. Okay, that is your velocity, and this is your acceleration direction. So in this case, motion direction is upwards. So in this case, speed decreases.
Sir, how can acceleration be negative in both cases?
You mean here and here?
That is, sir.
This and this.
There is, sir.
Yeah, so when the ball is going upwards, the earth is pulling the ball downwards or upwards?
Downwards.
When the ball is coming downwards, right? When the ball has reached the topmost point, the earth is pulling the ball downwards or upwards?
Downwards.
So you yourself answered your question. So what is your doubt?
Actually, I thought that the ball accelerates, right, sir? So I thought it was the acceleration would be negative, sir. So
acceleration is negative. Well, here we are talking about the direction, right? So we are, when you say minus, you are actually saying that the velocity keeps on decreasing, right? Here what happens is the velocity direction becomes negative because it's coming downwards. So since the velocity direction and the acceleration are in the same direction, the speed will keep on increasing. Are you following what I'm saying?
Sure, sir.
So take it down. Here the direction of motion and the acceleration direction are opposite. That's why the speed decreases. Here doesn't matter whether it's negative or positive because nature did not say that downwards is negative, right? Because just for our convenience, we have taken upwards is positive and downwards is negative, right? So that means you have to understand that nature does not put these signs. For our understanding, we are, taking this as positive and this as negative. So since the motion direction and the acceleration direction are same, motion direction and acceleration direction are same, speed increases. So this is a interesting concept. Very often you folks will miss this concept. Okay, so take it down properly. It's there in the handbook, but I think it's coming in the next chapter, the fourth chapter, but it's required for this discussion right now. And there is another situation like this, like a satellite going around the earth or a ball going around. You're pulling the ball to keep going around the circle. So look at this. The force is acting towards the center. The velocity is this way. So what can you say about that direction? So direction of the motion is perpendicular to the direction of the force. So you take a point over here. Velocity direction is this way. The force direction is this way towards the center. Everyone following what I'm saying? So that means here it's a totally different situation where it is perpendicular. So velocity or motion direction is perpendicular to the force direction. But I told you force is also, I can call it as acceleration direction because remember F is equal to ma. So m is scalar. So force direction and acceleration direction will be the same. We make a note. So this is scalar. So it means acceleration and force are in the same direction. To the force or acceleration direction. Now tell me, very important concept. Here I said when it's in the same direction, right? The speed will increase. Sorry, here. When both of them are in the same direction, the speed increases. When both of them are in the opposite direction, the speed decreases. When they are in the 90 degrees, right? Perpendicular to each other, right? It's not in the same direction, it's not in the opposite direction. So what do you think will happen to the speed? What happens to the speed? In order to increase the speed, you have to put it in the same direction. In order to decrease the speed, you have to put it in the opposite direction. If you put it in somewhere in between, right? You are not putting the force this way, you are not putting the force this way, instead you are putting it this way, which means the speed does not change. Okay, so take it down. So in this situation, speed remains constant. Anybody not following this? Very important concept. Okay. So that means the centripetal force or centripetal acceleration is only changing the direction. It does not change the speed. Okay, so I think we have talked about it earlier. Let's take it down one more time. Centripetal force, and you can also take it as centripetal acceleration, keeps the speed same. But it changes the direction. Any question so far? So take it down properly. Sometimes we might be repeating something, but nothing wrong in it. Okay. So all these basic concepts, it has to get into your head. Okay, when I say centripetal force, right? Anybody still copying? Can I change the screen?
Done, sir.
Done. Okay. So when I say centripetal force, right? Is the force coming from the ball or somebody who is standing here? He was pulling the string. Who is giving the force? Ball or the guy who is standing there?
The man.
The man, right? When you are standing here, you are making the ball to go around the circle. So it's not the force which is coming from the ball. So you are providing the force. So somebody has to provide this centripetal force. If somebody is not providing the centripetal force, the moment you stop this, right? If you stop giving the force, the ball will go straight. That means we say the centripetal force required or demanded. None of the book gives you like this. Okay, it's very confused. Most of the books confuse you a lot. So I would say it's not the centripetal force which is given. This is the centripetal force actually required or demanded. So if I want to, let's say my car is 1000 kg. Okay, maybe it will be 1000 kg or 2000 kg approximately, right? Depending upon the car. If you take a small Maruti car, it will be in the order of somewhere around 1000 kg. If you take other bigger cars, it will be in the order of say 2000 kgs. Okay. So let's say you're going at a speed of say 80 kilometer per hour. Okay. And let's say this road is kind of turning, which means there is a radius here. Okay. So it means this radius, let's say it's something like 10 meters or something like that. So that means if when you are taking a circular motion, right, what did I say? Whenever there is a circular motion, there is definitely a force which is acting towards the center. If there is no force acting towards the center, you will not be able to make a turn. Okay, this is an extremely important concept, so please pay attention. So suppose if I had some oil spill here, right? And you are going at say 80 kilometers per hour, so pretty high speed, 80 or 100 kilometers per hour in a highway. So what do you think is going to happen for the car?
The frictional force from the road will decrease.
Frictional force from the road will decrease. So what happens?
It moves towards the left side of the road, so it comes away from the road.
Okay, so are you saying that it's going to go this way?
No, sir, the other way.
You mean this way?
Yes, sir.
Any other answers?
Sir, it can go in anywhere, sir.
You go anywhere. So maybe you're saying the car will lose control, right? It will go anywhere. Well, a more accurate answer is, since the tires are losing the friction, right? What will happen is, instead of the car making a turn along this road, what will happen is the car will go straight and will be hitting this edge of the road. And that is kind of dangerous. Okay, why? Because there is no friction between the tires on the road. So that means I thought centripetal force is mv squared by r, right? So that means if I am going at a higher speed, 80 kilometers per hour, instead of 80 kilometers per hour, if I go at 100 kilometers per hour, the centripetal force, will it increase or decrease? Look at this formula and tell me whether the centripetal force will
sir.
increase
It
or
will
decrease. It will increase, right? So that means if I want to make a circular motion, right? You are supposed to increase the speed or decrease the speed. What do you do in real life? When you are taking a turn, do you really reduce the speed or do you increase the speed?
Reduce the speed, sir.
But then how come your formula is saying mv squared by r? So the centripetal force is increasing when you increase the speed. So this is what I told you. None of the books explains this properly. Okay, so listen carefully. It's not the centripetal force. Okay, you should not say centripetal force is equal to mv squared by r. You should say centripetal force required or demanded. So that means when you are going at 100 km per hour compared to 80 km per hour, the centripetal force required to make a turn will increase. So when I say the required amount is more, right? What does that mean? Your roads and the tires should provide that force. Okay. So it means take it down properly. So what I'm trying to say here is the friction force. Sometimes we will simply say friction, but actually what we mean is frictional force. Friction force between roads and tires provides the centripetal force. So now can anyone explain whatever I said, right? So now tell me, why are you actually reducing the speed instead of increasing the speed? The frictional force between the tires and the road, is it a fixed value or does it keep changing? Every 1 year or something, you go to the automobile shop and you actually do some retreading on the tires or you change the tires. Why do you do that?
Because the tires have been damaged due to the frictional force offered by the roads.
Yeah, so it's worn out, right? So because you keep on using it, so it's kind of worn out. So we want to either retread it. By retreading we mean, right, you are trying to put some kind of shapes inside the tires, and or you change the tires itself, right, which means you want to increase the friction force. So it means for a given tire on the road, right, the frictional force is kind of fixed. Okay, it doesn't change much. So that means this guy is what is actually providing you the centripetal force to make a safe turn. So that means when you are going at 100 km per hour, when you see a turn, you actually reduce the speed. Why? Because you are actually trying to reduce the demanded force. So when you are going at a higher speed, you need more frictional force. When you are going at a lower speed, right, the force which is required for making the turn will be less. Which means, suppose if I say this is say 1000 Newton, the frictional force is 1000 Newton. And let's say based on this calculation at 80 km per hour, let's say I'm getting a frictional force required, centripetal force demanded is, let's say 800 Newton. I'm just giving you some simple numbers to make it easy for you to understand. Okay, so don't write any of these numbers in the exams. Okay, so it's completely only for your understanding. Centripetal force demanded or required is, let's say here it is say 1200 Newton. So what I'm trying to say here is when you are going at 80 km per hour, the centripetal force required is to make a safe turn. Okay, or maybe here I should say it as centripetal force required or demanded to make a safe turn. Okay, so that means now look at this. I hope this will make sense. So that means the F friction is providing you only 1000 Newton. So if you are going at a speed of say 100 km/h, the required force, centripetal force to make a safe turn is this much. But the friction is providing you only this much. So that means what do? You are reducing the speed so that the required centripetal force will be reduced, or the demanded centripetal force will be reduced, so that this is the provider. So the demand should be less than the provider. Only then it will take a safe turn. Any questions? Any doubts? So now I hope all of you understand why you have to reduce the speed. Okay, even though the formula looks like as though if you are going at a higher speed, the centripetal force is higher. Well, it's not the centripetal force, it is the centripetal force required or demanded to make a safe turn. This is the required force. So that means we actually reduce the demand. Any questions? Any doubts?
Sir,
Yeah.
800 Newton is the centripetal force required for making a safe turn.
Safe turn at 80 km/h. And 100 km/h, when you are going at 100 km/h, let's say it's needing 1200 Newton. Again, these are all not real numbers. I'm just giving you some simple numbers to make you understand the concept. Do you follow what I'm saying?
Okay, sir. So 800 Newton should be less than 1000 Newton. That means the centrifugal force required should be less than the frictional force, no, sir?
Centripetal force. Okay, you are right. I'm supposed to write as CP, centripetal force. Okay, I called as F is force. Okay, CF is fine. Well, let's say you need 800 rupees to buy something. Okay, so, or let's say your dad is giving you only 1000 rupees. So you want to buy some dress. So one is 800 rupees, the other one is 1200. Which one will you be able to buy?
800.
That means the demand has to be less than the provider. So it means this is 800. So that means the demand is 800 and the provider is 1000, means you can make a safe turn because 1000 means it's giving more than what is required. Are you following what I'm saying?
Yes, sir.
That means you can take a safe turn. In this case, when you are going at 100 km/h, let's say the centripetal force required is 1200, but then the friction is able to provide only 1000. What happens? Then the car will not be able to make a safe turn. It will go and hit the barricade, the sides. So if you are going at a very high speed and if that friction is not sufficient, the car will try to go almost straight and hit this. Why? Because Newton's first law. Because when the frictional force is not trying to turn it towards the center, it will go straight according to Newton's first law. Following or not?
Yes, sir.
Anybody having any confusions, any doubts? So now that you understood what is centripetal force required and centripetal force provided, right? So the centripetal force is provided by the friction. Okay. So let me give you one more simple example. Look at this. I'm sure all of us have experienced this situation. You have a divider in the road. So you are in a car or a two-wheeler. So when you are trying to make a U-turn, right? Have you seen people doing a U-turn? So they will try to come like this. This is path one, or will they do like this? Which one is what? What is that you have observed very often?
Path
Path
1.
one, sir.
path 1. Why can't you take path 2? Is it easy or difficult to take path 2?
It's difficult.
It will be very
Difficult,
difficult,
sir,
right?
and there's also a great chance of collision, sir.
Collision. Okay, I'm assuming that there is no other car here. Oh, you mean the divider here?
Yes, sir, the
Okay.
divider, sir.
Okay. So the point here is, right? So look at the diagram carefully. So you have a circle like this in the first path, which means the radius is somewhere here. Okay, you have to take an imaginary point where you can, imagine like a circle. And if you take the smaller circle, this is your small r. So now tell me, centripetal force, we gave it as mv squared by r. So when the r is bigger, what happens to the centripetal force?
Decreases, sir.
Decreases, right? So that means why would you take a bigger path? Again, I want you to remind yourself, what is this, centripetal force or centripetal force demanded? What is this? This formula mv squared by r.
Required or demanded for a
Required or
safe.
demanded? Required or demanded. So that's why I keep on saying your books doesn't tell you this. Okay, so you should not study it as centripetal force is mv squared by r. You should study it as centripetal force required or demanded for a safe turn. And that is what is your mv squared by r. Now, can you explain me, based on this formula, can you explain me why do you think we are taking path 1 instead of path 2? In path 1, the radius is bigger. And the radius is bigger, what happens to the centripetal force required?
More, sir.
No, when this is bigger,
And decreases.
It will
centripetal
decrease.
force required will be decreased, which means who is providing the centripetal force when you take a turn? Who is providing the centripetal force in the case of a car and taking a turn? Friction, right? Again, it's the same friction, right? If you have a oil spill, you will not be able to take a turn at all, because friction between the road and the tires will become almost zero, which means you will not be able to make a turn. Okay. So what I'm trying to say here is, as the R increases, the centripetal force required will be decreased, which means it's safer for you to take this turn compared to this turn. So if you try to take this turn, this R is very small, which means the centripetal force required will be very high, which means probably your tires might provide you the required friction, or it may not provide, which means this will become dangerous. So this is safer. This is dangerous, particularly if you are going at a higher speed. Okay, so make a proper note. One more important concept, okay, just for your understanding, I started with the car taking a turn, okay, to make it easier. So in reality, there are a lot of things which are going around a circle. Can anyone tell me any other examples which you can think of which is going around a circle? That's all. Car taking a turn. Anything else? How do you think the moon is going around the earth?
In a circular path.
Almost in a circular path. Okay. So they say it's slightly elliptical, but almost circular. Okay. For our practical purposes, we can, for our theoretical calculations, right, we can assume it to be a circle. So that means it's something like this. Okay. So what is making the moon to go around the earth? Is there any friction between the moon and is there any floor underneath? Is there any friction there to go around the circle? What is causing the moon to go around the earth?
Centripetal force.
Centripetal force. Well, centripetal force is a force which causes the circular motion. But what I'm asking is, who is providing the centripetal force?
Gravity.
Gravity. Yeah. So it's the gravity which is causing the moon to go around the earth. So that means the force of gravity is acting towards the center of the earth, and that is what is going around or making the moon to go around. Okay, we'll talk more about this later. You may be wondering, sir, if the force is acting this way, why can't the moon just fall into the earth? If I throw a ball here, right, the ball goes all the way here and then falls into the earth. How come the moon is not falling into the earth, right? So that's an interesting question. We will come back to it later. So for now, we are going to simply say that the gravity is what is causing the moon to go around the earth. Similarly, the earth and all the planets are going around the sun because of the gravitational pull between the planets and the sun. Okay. So that means gravity is the provider. The centripetal force mv squared by r is the demander. Okay. So take it down here. So gravitational force provides, the very important keyword, provides the required centripetal force. CF stands for centripetal force to go around the circle. Okay. Let's take, anybody still copying this? Quickly copy this.
Yes, sir.
After copying, let me know. You don't have to take down this ball. Okay, we'll talk about that later. Copy it. Okay, now let's talk about another situation. I'm sure in your chemistry you must have studied nucleus and the electron going around the nucleus, right? So nucleus is in the center, and then the electrons are going around the nucleus. Okay, so this is one of the atomic models. So the electrons are spinning around the nucleus. So what is causing the electron to go around the nucleus? If it is going around a circle, right, there must be a centripetal force. There must be a force acting towards the center. What is the force which is causing the, or who is providing the centripetal force?
The charge.
Charge. Okay, slightly correct, not accurate. Anybody else?
Electrostatic force.
Yeah, so nucleus, in nucleus, what are the particles you have?
Protons and neutrons.
Protons and protons.
Neutrons and protons. Neutrons is neutral. Protons is positive.
Positive.
So that means nucleus is positively charged or neutral or negative?
Positively charged.
Positively charged. Electron is negatively charged. So you know that there is a force of attraction between plus and minus. And that is what we call it as electric force of attraction. Okay, so that means the electric force of attraction is what is providing you the centripetal force. So that means you can call it as electric force or electrostatic force. So electric force of attraction. Similar to this getting attracted, this is also getting attracted this way, but generally we like to show only this one. Or you can also call this as electrostatic force of attraction. Okay, so don't get confused by the different names, it's all the same. So that means electrostatic force of attraction provides the centripetal force. To go around a circle. Okay. In the case of, okay, if anybody is copying, quickly copy this.
Done, sir.
Anybody else copying? Can I change the screen?
Sir, 1 second, sir. Done, sir.
In the case of ball, right? I told you somebody is standing here, then they are trying to. There is a string over here, and there is a ball here, and then it is going around like this. Okay. Who is causing the circular motion? Who is providing the centripetal force in this case?
The man, sir.
Man, but more specifically, we say that there is a tension in the string. So the moment you, let's say the thread was very, very thin, right? There is a possibility that the thread might get cut. So if that happens, what happens? It will start going straight. It will not go around a circle. So that means the tension is provided by the man. So we call this as the tension in the string. Tension in the string causes or provides the centripetal force required for circular motion. Okay. Car example, I already talked about it, right? So if you want, you can take it down. So you must have taken it down properly. So in order for the car to make a proper turn, right? The friction between the road and the tires provides the centripetal force for circular motion. Any questions? So I have given you some simple examples which you are aware of. Moon going around the earth, gravity is providing centripetal force. Electron going around the nucleus, electrostatic force of attraction provides you the centripetal force. A man spinning the ball around him, so the tension in this the tension in the string provides the centripetal force. The car taking a turn, the friction between the road and the tires provides the centripetal force. Okay, I just given you some simple examples. You can think of other examples also, right? We will be coming across some problems like conical pendulum. So if you have a pendulum like this, and let's say this is the center, and let's say it's kind of spinning around a circle like this. So this is like a cone. So you'll be seeing a cone here. So this is the circular motion. So that means we say the way we draw this diagram is very simple. So you know that the mg is always acting downwards, mass into gravity. So we will be splitting this into two components. Okay. So we'll be saying that, how will I do this? So I'll be taking one here, and this, but then that will be in a different way. Okay, so there is a tension in the string over here. So what we will do is we will write this as, suppose if this is theta, this will also be theta. And I would call this tension can be resolved into two components. You should know what is the resolution of vectors. So I can resolve this into two forces. Remember, tension is also force. Okay, we call it by a different name, but tension is also force. Whenever it is a rope or a string, we don't call it as force. Instead, we call it as tension. Tension in a rope, tension in the string. So this tension, I will be splitting this into T cos theta and then T sin theta. Can anyone tell me, the circle is here, which force is acting towards the center? T cos theta or T sin theta or mg? Or T, which one is acting towards the center?
T sin theta.
T sin theta, which means we will be saying that T sin theta provides the centripetal force to go around the circle. And this is called conical pendulum. So take it down. Conical pendulum. These are the type of questions you will be getting in your entrance exams. Okay. So if you understand the concept, you can immediately say that, okay, T sin theta is what is acting towards the center. Okay. So we'll be getting little more complicated problems in this. Okay. But you should understand the concepts, basic concepts. Okay. So as I told you, I did not do any derivations at all. Okay, derivations are the easiest thing. Mathematics is the easiest thing. Okay, understanding this concept is more important in my opinion. Most of the time students do the derivations, write it in the paper and get the marks, but they don't understand any of these concepts. Okay, so that's why I wanted to do the concepts today first and then do the derivations later. So that means what we have seen today is we have studied something called uniform circular motion. Okay. We studied something called uniform circular motion. We studied about, which one is changing, speed or direction, right? So then we talked about something called centripetal force and centripetal acceleration. That is what is responsible for the circular motion. And then we talked about how the force direction and the motion direction affects the speed. Does the speed increase or decrease, and what happens in a centripetal force? Centripetal force does not change the speed. That's what we studied here. And then we understood a very important concept, which is mv squared by r is not centripetal force. Mv squared by r is centripetal force required or demanded to make a safe turn. That means your provider, whoever is providing the centripetal force, such as gravity or tension or friction or electrostatic force of attraction, these forces have to be more than this value. Only then it will make a turn at a particular speed and particular radius. Otherwise, it will not be able to make a turn. And this is the reason why we reduce the speed and increase the radius to make a safe turn. And then we talked about different forces in nature provides a centripetal force to make something go around a circle. So whenever there is a circle, there is a circular motion, there is a centripetal force. Okay, so I'm going to stop here. Next class we'll be doing the derivation. So the mathematics is kind of easier, but you should understand this properly. Go back and study this. Okay. And if you have doubts, stay back. Otherwise, you can leave. Thank you all. Bye.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you, sir.